So today we want to continue with triangle congruence. We understand what it means now for two triangles to be congruent. All 6 of the corresponding pairs of parts have to be congruent. We have 3 pairs of angles and 3 pairs of sides. Well, my question is, do you have to have all 6 of those pairs congruent to know that these two triangles are congruent? What if we only had 5 pairs of combination of angles and sides? Well, I think most of you would agree that we can still say these two triangles are congruent, because we know if 2 of the angles in a triangle are equal, when we subtract those from 180, the third angles are also going to be equal. And so we're going to have all 6 pairs of corresponding parts congruent, which means our triangles are congruent. Maybe we don't need that though. What if we only had 4 pairs of congruent parts? Let's say, for example, 2 pairs of angles and 2 pairs of sides. Do you think that you could make 2 different triangles with that information, or do you think every triangle you made would always have to be exactly the same as the first? Well, you probably can guess, but it turns out that that's enough information. So we can go with 4 pairs of congruent corresponding parts and know our triangles are congruent. You guessed it, what's next? What if we only had 3 things? What if I told you that we had 2 pairs of corresponding angles congruent and 1 pair of corresponding sides congruent? Do you think that's enough to guarantee these 2 triangles are congruent? The answer to this is sometimes. In this particular case, the answer is yes. But what about this case? And let me put them both up at the same time. In the first case here, we have 2 pairs of angles and a side. In this case, we have 3 angles. We have 1 pair of angles, then we have a second pair of angles, and then we have a third pair of angles. Will that guarantee that the triangles will be congruent? If I told you in your GeoGebra software, make a triangle where one angle is 60 degrees, 1 angle is 50 degrees, and 1 angle is 70 degrees, and everybody in the class made a triangle on GeoGebra on their iPads, would everybody's triangle be exactly the same size and exactly the same shape? Well, what if we printed them all out and cut them out and measured them? Would they all match up, do you think? Well, what if somebody went over to the copier and enlarged their picture to 150%? They'd still have the same angles. They'd still have, a 50 degree and a 60 degree and a 70 degree angle, but their triangle's much bigger than somebody else's. So it turns out just having 3 angles is not enough. Whereas in the case before that, if we had 1 angle and then another angle, and then a pair of sides, it turns out that does work. So if we have all 6 pairs of corresponding parts congruent, we know the triangles are congruent. Even if we have 5 pairs of corresponding parts congruent, we still know every triangle is going to be congruent. And even with 4. But once you get down to only 3 pairs of congruent corresponding parts, that's where sometimes the triangles will be congruent, but not always. And so we have to break that down into what 3 things are we going to be given so that we know the 2 triangles will be congruent. Alright, well, these are the situations. You can prove that 2 triangles are congruent with only 3 pairs of matching parts congruent, but only if they're in a certain order. The first If you have all three pairs of corresponding sides congruent, you know the triangles are congruent. If you had two pairs of corresponding sides and the angle between them has to be the angle between them, then that's also enough to guarantee the triangles are congruent. If you have two angles and the side between those two angles matching up, then you know the triangles are congruent. And even if you have two angles and a side that's not in between them, as long as they're corresponding parts, then we know the triangles are congruent. So those are the cases that work. Now at first this may seem a little strange, so let's do some examples so you get the idea. Alright, in this example, we have two triangles, and we know that this side's congruent to this side's congruent to that side, and that side is congruent to that side. So therefore, we know that these two triangles are congruent, and we know that by the side-side-side postulate, which means we have three pairs of corresponding sides congruent. Now in this case, let's mark the pictures for what we have. We have this side's congruent to that side. This side is congruent to this side. And this angle is congruent to this angle. Notice we have two sides and then the angle between those two sides. So that means that, yes, these two triangles have to be congruent. And we know that by what's called the side-angle-side postulate, or SAS. We have a pair of sides, then a pair of angles, then a pair of sides. Alright, before I go to the third type, there's a worksheet you should have been given, and let's jump to that and look at some examples with that. Alright, so here we have this first picture, and we have one pair of sides and one pair of angles. Well, that's not enough. We need something else. But looking at the picture, we do know something else. We know that that side is congruent to itself. Both triangles use that one side. So now what we actually have, we have a pair of sides, and then a pair of angles, and then another pair of sides. So yes, these triangles are congruent by side, angle, side. Look at the next picture. Same thing here. These triangles share a side which we know is congruent to itself. So we have, in the top triangle we have one side, then we have an angle, and then we have another side. In the bottom triangle, we have a side. Oh, but wait a minute, we don't have that angle, and then we have the other side. So notice, in the top triangle, if I cover this up, in that top triangle, I have two sides and the angle between them, but in that bottom triangle, I have two sides but the angle not between them. So in this particular case, we cannot say these two triangles are congruent. So that one's a no. Let's look at number 3. Kind of getting the idea with these. So in this picture, these two triangles also share a side. Now in this one, if I go back to covering them up, in the top triangle we have two sides with the angle between them. And in the bottom triangle, we also have two sides and the angle between them. So these two triangles are congruent by side, angle, side. And we'll do one more. If you look at number 4, what do we have in the first triangle? In the first triangle, we have a side, and then an angle, and then a side. And the angle's between the two sides. In the second triangle, we have a side, we have another side, but the angle is not between. It should be up here, but it's not. So therefore, these two triangles we cannot say are congruent. Okay, let's go back to the notes. The third type of way we can prove two triangles congruent. Actually, let me back up a little bit. Here's another example. We cannot say these two triangles are congruent. In this picture, I have 11, matches up with the other side that's 11. Then I don't have the angle to the right of it, just like I don't have the angle to the side of that 11. And then I have the 15 sides are congruent. But I don't have the angle that's between those two sides. I have a different angle. I have an angle that's not between them, but it's the same angle in both. So you might think, well, these two triangles look like they match up. But it turns out in this one, we have an angle, the green angle, and then we have a side, and then we have another side. Well, we know we shouldn't have that, and it turns out we're lucky. It doesn't work. And if we go the other way, we can say we have a side, the 15, then we have another side, the 11, and then we have an angle, the 47 degrees. So either way we write this, SSA or ASS, that does not work. So that is not one of the ways we can prove triangles congruent. One of the ways we can prove triangle congruent is by angle side angle. And in this case, if we have two angles congruent, we have a 71 congruent to 71, and 53 congruent to 53, and then we have the side in between them congruent, then we can say, yes, these two triangles are congruent. And we say they're congruent by angle side angle. Now, because of what we know about triangles and all the angles add up to 180, right now I have 71 and 53. That's 124 degrees total. If I subtract that from 180, I'm left with 56 degrees. I know this angle is 56, and this angle is also 56. So even if I was given, let's say, 71 and 56, and not given the 53, then I would have two angles, and then the side that's not in between them. So in that case, we'd have an angle, and then another angle, and then a side. This is actually the same idea as angle side angle. So that's why we really have 4 different ways we can prove triangles congruent. So here they are. Proving two triangles congruent. If you have all 3 pairs of corresponding sides, if you have 2 pairs of corresponding sides and the angles between them, if we have 2 pairs of corresponding angles congruent and the side between them, or if we have 2 pairs of angles and then another side. And these are the only 4 ways we can prove 2 triangles are congruent with 3 pieces of information given. So let's do a couple quick examples. Which postulate guarantees these triangles are congruent? Look at the first one here. We've got a side, then we have an angle, and then we have a side. So these are congruent by side, angle, side. This example, we have a side, we have another side, and then the third side is the same for both triangles, so we know that's congruent to itself. So this one tells me that I know the triangles are congruent by side, side, side. What do we have in this one? We have a pair of angles congruent. We have a pair of sides congruent. And that's all that's given. But from what we've learned already, we know that these two angles are congruent. Those are called vertical angles. Hopefully you remember that. And we know vertical angles are congruent. So in this picture, I know these two triangles are congruent by angle, side, angle. I have two angles and the side in between them for each triangle. Let's do one more. How about this picture? What do we have? Well, we have that side matches with that side. We don't have this angle here, but we do know these two sides match. And then we have an angle. So depending on which order you do this, you can think of it as we have an angle, and then we have a side, and then we have a side. Or you can think of it the other way. We have a side, then another side, then an angle. That's not one of our four. So this doesn't work. We don't know if these two triangles are congruent. They may be, they may not be. It depends. We need more information. Alright, let's look at another type of question. What if I give you a picture of some triangles, and I want you to tell me which pairs are congruent? Let's start with the first one here, the blue triangles. We have two angles and a side that's not between them. That's one of our four postulates. We know by angle, angle, side, these two triangles have to be congruent. Let's look at the next one. We have a side, then another side, then an angle. That's not one of our postulates, so that one's a no. Look at the purple triangles. Once again here we have two angles, and then a side that's not between the two angles. So yes, those two triangles are congruent by angle, angle, side. Look at this fourth picture with the black triangles. We know that that side's congruent to itself. It's a side for both triangles. So what do we have? We have a side, and another side, and another pair of sides. So yes, these two triangles have to be congruent by side, side, side. And finally, looking at this picture and remembering what I mentioned about vertical angles, we know those angles are congruent. So we have two sides and the angle between those sides. So yes, these triangles have to be congruent by side, angle, side. Okay, so now you have some worksheets to work on, and hopefully you'll be able to understand when two triangles are congruent and when they're not, given certain bits of information.